Good morning, everyone. Thank you for joining us today for our HashiCorp Solutions Engineering Hangout hosted by Roger Berlin. Today, we are focusing on HashiCorp Nomad. Nomad is an easy-to-use and flexible cluster schedule that enables organizations to automate the deployment of any application on any infrastructure at any scale. Roger will show you how microservices can be deployed with Nomad and discovered by Console, along with how services are redeployed if the node they run on fails. After the demo, we will take live questions from the audience. I also want to note that this Hangout is recorded and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. The demo will be just 15 minutes and will allow up to 30 minutes afterward for questions. So with that, let's go ahead and get started. Take it away, Roger.
Okay, thank you so much, Amanda. So again, my name is Roger Berlin. I'm a senior solutions engineer here at HashiCorp. I've been here about, I think 10 months, getting close to a year. And as Amanda said, today's demo will focus on running microservices with Nomad. And it's Nomad together with Console. Console's providing the service discovery for the microservices so that they can talk to each other. But the focus is mostly here on Nomad. And this is mostly focused, well, anyways, yeah. So I do have some slides to show you first, just to set the stage for the demo. I think the demo will make more sense if I do this. So let's go in here and let's try that. Hopefully you can all see the screen. I'm sure Amanda or Brett will tell me if there's any issues. So I'll very briefly talk about Nomad and Console. Then I'm going to talk about the particular application I'm using, which is called SockShop. It's actually an open source microservices demo that's out there, and you'll see the URL for it. And then I'll talk about essentially how I'm using Nomad and Console and some other things as well for this demo. This is actually a demo that shows off all the HashiCorp products, almost all of them, but I'm going to kind of focus on Nomad and Console and not pay as much attention to how Terraform and Vault and Packer are used. Okay. Sorry, my thing is not advancing. There we go. So Nomad and Console, like I said, very briefly, Nomad deploys and manages applications across clusters of many virtual and or physical machines. Amanda already kind of mentioned that. And in particular, what's interesting about Nomad is not restricted just to containerized workloads. Like in other words, you don't have to have everything be in Docker. It can schedule Docker containers. It can also schedule other types of containers, but it can schedule non-containerized applications, like job applications and pretty much anything that you might, want to invoke, any kind of binary or script that you want to invoke from a command line. Now, Console provides a distributed service networking layer to register, connect, secure, and configure applications across dynamic distributed infrastructure. There's a lot of exciting stuff going on with Console, and I'm not going to be using that, but there's something, new capabilities that are called Console Connect, which involves securing communications between different services, in a way that focuses on the services themselves rather than IP addresses. And it kind of does service-to-service security as opposed to firewall-based security. So it's very interesting. I won't be using it, but definitely something to be aware of if you've already, some of you might have been more familiar with Console in terms of service discovery and as a distributed key value store, but it's kind of expanding its scope. So about the SockShop application, as I mentioned, this is an open service application. It simulates an e-commerce website that sells socks. It's built from microservices, or the microservices are written in several languages, Node.js, Java, and Go, and there's several databases as well, MySQL and MongoDB in particular. This can be run on many platforms, including Nomad. I have the URL here. If you guys want to, you can see where that is. Just search for microservices-demo. And you'll find both there's a GitHub repository and you'll find actually there's a page that shows up a website for it. I mentioned earlier this demo does use essentially all of the HashiCorp products except for Vagrant, but we're going to focus on Nomad and Console. And I do have the source code for what I've done here, and there's actually a guide. You could actually do this on your own, and I'll show that to you a little bit later. So you can actually try running through this on your own. This is the architecture for the different microservices. We have a front-end UI. I'm trying to find my mouse. Okay, my mouse has disappeared. 1 second. Okay, I'll just, up top in the left, we see hold on one second, let me just see it. Oh, there it is. Let's try going, I guess it disappears when I'm in presentation mode, or I'm just not able to, there we go, now it's there. We have the front end application written in Node.js that's talking to four what are called the main services written in Go and Java. Each of the main services communicates with a database, and as I said, those are Mongo or MySQL. And we have some external services that simulate, payment processing and shipping. And there's even this thing called QMaster, which is the only, all these applications, by the way, are deployed by Nomad as Docker containers using something called the Nomad Docker driver. They're colored blue. The QMaster is deployed as a Java application using the Java driver. And so that QMaster, it's not too important for purposes of the demo, but what it does is it picks up messages from this RabbitMQ messaging server. It picks up the shipment messages. So imagine the QMaster is representing somebody like FedEx, or UPS, right? That's actually receiving the shipments that were placed onto a message queue from the e-commerce vendor. Okay, so that's what's going on there. I have two more slides to briefly talk about how various HashiCorp solutions are used in the demo overall. I actually used Packer to build the Amazon EC2 image, the AMI, and that AMI contains Nomad Console and Docker and everything else needed to run the microservices. So for instance, I actually just rebuilt that yesterday. I ran Packer yesterday to update the versions of Nomad and Console, and also to add an extra option to make Console use a new UI that we have. I used Terraform to provision everything to AWS, except for an existing Vault server that I already had running, and because Terraform talks to that. Nomad schedules and manages the SockShop microservices. Console's used for service discovery. Console's also used as a distributed key value store for a Docker overlay network that I'm using. So if you're familiar with Docker, there's something called overlay networks that can span multiple hosts, and I'm actually using one of those. And a Docker overlay network needs a key value store, and I'm actually using Console in that fashion as well. So Console's doing two things here. And then Vault is dynamically provisioning AWS credentials to Terraform and provides the database passwords to Nomad, which Nomad then takes those passwords and passes on to the databases that it, the databases that it creates or triggers. Okay, so Vault is our secrets management solution. There are some other technologies used here as well. Most of the SockShop microservices run inside Docker, but as I mentioned, so that's obviously I'm using Docker, containers, and images. I am using a Java application, as I mentioned, and then I'm using this overlay network together with Console. And of course, everything's deployed in Amazon EC2. So that gives you pretty much a full picture of what's going on here. So with that, I'm going to start the demo. Let me get rid of these slides for now, at least. Let me just maybe mention, I'll point out that I have a particular part of this deployed here, but we have a website, or we have a number of different, HashiCorp in GitHub has a number of different projects that provide all kinds of useful information for people learning about our products. So there's Terraform guides, Vault guides, Nomad guides, and Console guides in particular. Under Nomad guides, you'll find there's an application deployment directory with microservices. In fact, why don't I just go up here and go to microservices. You'll see this is where you have a complete README that tells you how you could go about deploying this on your own. So how you could use, and by the way, this doesn't need, this runs with fine, and I'm using Nomad open source. So you can use Nomad and Console. Actually, this is Nomad Enterprise is used, I guess, in terms of, I think we need it for the UI. I think that's part of Nomad Enterprise. But in any case, this kind of describes, the process of what you need to do to deploy and how to configure your Vault server. And there are some links in some cases to various external things about setting up Vault and all that. But this pretty much walks you through the whole process and how to provision this with Terraform, right? And verifying that Console and Nomad are running, verifying the SockShop deployment, and then using the SockShop application. So this is a kind of comprehensive guide that's available to you for doing this all on your own. Okay, and then I'll come over here. Notice right now, I've already deployed this. If we look at Terraform Enterprise, I deployed this with Terraform Enterprise. I have a particular workspace here called Nomad Console Microservices Demo. This had a number of variables associated with it. And again, I'm not going to focus on Terraform, but this had I basically said here I wanted 3 clients, right? I wanted 3 servers. There's some other information, that affects the names of these things. And we can see that, this was deployed successfully. And if I view the apply here, I can see some outputs. I see that I have 3 client IP addresses, and I have I have public and private addresses, and I also have my public server addresses and some instructions on how to, access, how to SSH over to one of the servers, the first server in the list, and how to bring up, the console UI and the Nomad UI, which I've done over here, right? So I have my Nomad UI and my console UI, right? And this is one of the clients where I'm actually accessing the application. So I'm not going to say anything more about Terraform. Here we can see though in EC2 I do have 3 clients and I have 3 servers running, right? I'm filtering to just show those EC2 instances. Okay, so with that, let's take a look at Nomad. Nomad, as we can see, I have my server set up, one of which is the leader of the cluster. Nomad, just like Console and Vault, they all have a notion of a leader of the cluster. So I have a particular server that's the leader. We have clients as well. They're all ready, and I have a job. In Nomad, we talk about setting up a job. And actually, the job, just to show you what that looks like, is over here underneath Shared, Jobs, SockShop Nomad. A job basically, it's JSON file, or it might actually, it's HCL. Well, it's either. But we have our own thing called HashiCorp language, so it's probably actually HCL. I forget. Anyways, the SockShop job has a number of things at the top level. We have certain constraints, like I want to deploy to Linux. Then I start getting into my different groups. I have groups of tasks. So I have my front end group, and there we can apply constraints like I want each of the front end applications to go to its own distinct host because they run on a fixed port. The front end application here actually ends up running on a static port 80. So I don't want to have more than one of those on any particular node. But other than that, Nomad is pretty much free to schedule these applications to any node it wants to based upon available resources, right? That's the whole idea of something like Nomad, is you're able to bin pack your software, right? Whatever your applications, rather than you deciding where to deploy them, let Nomad decide where to deploy them, let Nomad move them around as necessary, and then let Console make sure that these services can find each other no matter where they are, even if they move. We'll see later, I'll kill one of the clients and some of the services will move, but they'll still be able to find each other because of Console. So anyways, we have this notion of a task. We can see that most of these tasks are using the Docker driver, and then there's a specific Docker image that they're loading, right? So, and we could go through the whole list. Some of these things are doing some stuff in terms of talking of Vault. It may not be entirely obvious, but we have this thing called, effectively it's using something called console template, and this with secret effectively says that it's getting data from Vault. There's a Vault configuration that I set up as part of the server. In fact, we might see something in here. Let me just move this down. I think if I search for Vault in here, I think I should find Vault in this file somewhere. There we go. Vault policies. There might be one more. No, it's just the Vault policies. But I did configure Vault. I think it's part of my Nomad configuration itself, not this file, but a different file. I configured Vault. In any case, so the purpose of having Vault here is so that some of these databases can actually determine their root database password from Vault. So if I need to change those, I can change them in Vault, and the databases will automatically use the new passwords the next time they start. Okay, anyways, we have all that. We have a whole bunch of these apps. I'm not going to go through the whole list, except to talk about down near the bottom, we get into the back office application, and that's where we get to the QMaster app, and that is the one that is different. That's the one that I had colored green. That's using the Java driver, and we can see that this is loading up. The jar file is being downloaded from an S3 bucket, right? So this is coming from an S3 bucket. Okay, with that, let's go over here. Let's look at the job. Let's see what we have. Currently, we have everything's green. We have 9 things running. And down here we see everything is green as well, and we're getting some metrics about them. So everything's good. I could also go look at the history of this. I could look at deployments for this, and I can click on the last deployment, and I can see status about that deployment. I have 9. Desired was 9 over here, and I've managed. Nomad was able to place all 9 things, and all 9 of them are currently healthy, right? So that's all good. This canary things, by the way, is talking about blue-green deployments where you can deploy in a blue-green style. So that's kind of neat, but I'm not actually using that. Okay, so let's do this. So let's look at the application itself. If we go into the application, let me log in just to show you that all these microservices are really able to talk to each other, right? I mean, showing you the app's not important. It doesn't teach you anything about Nomad or Console, but it does demonstrate that this is a real, application in which these things are talking to each other. And so that logged in successfully. I logged in as eBurger, and hopefully that's just still loading. And I hope, but there we go. That was a little slow. Here we go. I've just gone into the catalog. So notice every time I'm doing anything here, when I logged in, every time I do anything here, I'm using that front end microservice. If you remember from the diagram, I'm using the front end microservice, but when I log in, I'm also interacting with the user service, right? The user, one of the main services, the user service and the user database. When I go to the catalog, I'm interacting with the catalog service and the catalog database. When I add something into a shopping cart, like I just did, I'm interacting with the cart service and also the cart DB, the cart database, right? And now we here see the shopping cart, and I can proceed to checkout. And sure enough, I have another order. Now I had placed 2 orders previously, so they're still there. And I can view my orders, right? And that's interacting with the orders service and the orders database. And when I placed the order, by the way, that would have caused all those backend services to be invoked as well, right? So at this point, I've used all the different services, all 13 or 14 of them. And that's just an example of doing that. But now let's come and take a look at Nomad. If we come in and look at if we come in here and look at this job, let's find, for instance, catalog. If we look at catalog is currently running on this particular client. So let's see what's there. It's running on this client, 10.0.1228 is the private IP. Now, by the way, I could have figured that out a different way. I probably could have come into the client if I picked the right one, and I could have seen what things are running on it as well. But in any case, that was the one I did. So there was, if I just go back a screen, 10.0.1.228 was the client that's having the catalog in particular. And I'm picking that one because what I'm going to do now is I'm going to actually find that one. 228 is the first one. I'm going to actually stop or I could terminate it. I'll terminate it. So I'm going to terminate that instance. And let's see what happens in Nomad. It might take a little bit of time, but we should see some activity here. This should update automatically. We're going to start to see some things will turn black. I don't think I have to refresh, but let's just do it anyways. It hasn't quite caught up, right? Because it's still figuring out that the servers, that particular client was killed. But there we go, right? So now we see a change. We see some things that turn black. I'm getting activity. Now the red banner message about a distinct host filter 2 nodes, that's okay, actually. I expected that because remember I had a thing in my Nomad job specification that said I don't want to run the front end on more than one client, more than one node. Sorry, I don't want more than one instance on a single node because of that fixed port 80. So that's why we're getting that warning. And in fact, I actually could do this in a better way, and I should update the demo. Instead of having this constraint, instead of saying that I want 3 instances of this, what I could do instead is I could say that I want 1 instance of this on each node. That would actually be a better way to do it, right? So I wouldn't even need, I could have that constraint, but instead of saying count equals 3, there's a way for me to say run 1 of these on each node that I have, which is what I wanted in any case. So that would be a better way to do it. In any case, but we see here that everything, front end is still not, front end has 1 gray thing, but that's okay because we're limited to 2 clients now. So let's do this. If we go back here to Terraform, I think when I highlighted the one that I picked, I think was actually we're at 5991.222. That one is actually the second one. So that's okay. If you remember, the one I actually killed, the client I killed was the first one. But we can verify that, right? We can go back, we can go in here and start to see, hey, can I go home? Can I go to the home screen? Yeah, like in other words, this client is still running, right? I can see my orders. But more importantly, I can now go into the catalog and I can see that the catalog, remember, there's only 1 instance of the catalog service, right? That catalog service, even though it got moved, right? We see this catalog was moved around, right? We lost one, but it was redeployed, right? This is the one, it used to be here on this client, on the 10.0.1.228, the one I killed. And now it's over here on 10.0.1.230, right? So that was moved, but the application is still working. I can, add things into a shopping cart. I can go to my shopping cart. I can check out again. And now I have a 4th order and I can view my 4th order, right? So everything is still working. Now, the only other thing that I'd like to show during the demo, unless I forgot something, well, console, here's the console. We see all the services. I should have shown this earlier, but all the services are currently running. This won't necessarily record the fact that there are failures because I'm not telling console how many instances there should be of anything, but everything is currently up and running. I can look at my nodes. I I mean, one of the nodes has been terminated, right? So now this shows 5 nodes. It would have shown 6 nodes if I had shown this to you earlier. Key value, I mentioned that Consul's used as the key value store for my Docker overlay network. So we see that here, right? We see some information from Docker being written into Consul. But over here, there's one more thing I want to do, which is if we go here to the servers, in fact, actually, I want to look one more thing. If we look at the Nomad, remember earlier I showed you the Nomad servers. The one that's the leader is currently 10.01.132. Let's kill that. So that one is not this one, but I think the second one. Okay, nope, not that one either. Must be the third one, 10.01.132. Let's make sure. Yeah, that's the leader. So let's terminate this guy as well. Instance state terminate, right? When I terminate that, let's see what happens too. We're going to see it takes a little bit of time, but the leader will change, right? Eventually, it takes a little time, but eventually the other server will be marked as dead, as failed or left. But I can refresh this maybe. So which one did I just kill? I just killed 132. So we see already that the leader now has changed, right? Now 1.63 is now the leader. So you see that Consul has resiliency, and I can still use this UI. I can still look at my jobs. Nothing's changed. Like this would be totally transparent. If you didn't happen to be looking at the servers, you wouldn't know that the leader had changed. If you were just a user, right? So this is just showing resiliency both with regard to Nomad clients, and the clients are the ones to which you're deploying the jobs, right? You're running your jobs, right? And then also with regard to the servers. Okay, so that is pretty much it. We had the job specification, we had the slides. I ran through the application. So I'll stop share. Well, I'll keep sharing in case I need to show anything else. But I think we could start to open it up to questions, Amanda.
Okay, thanks, Roger. And we do have some, so if anyone does have questions, yes, feel free to just enter them in the question section in the portal. So the first question, Roger, so someone's asking, does Nomad know how many CPUs each AWS instance has and pack Docker containers appropriately?
I believe the Nomad can detect. I think there is something built in Nomad where it is able to go out and figure out how much resources. Definitely resource management is an important part of Nomad, and I'm pretty sure that each Nomad instance is able to figure out, I forget where this is documented, but I am fairly sure that Nomad is able to somehow figure out the resources for any particular node that it's running on the table, whether it's AWS, a cloud-based AWS, Google, Azure, or whether it's, in a data center. I believe that Nomad is able to determine CPU. One thing we might be able to do, how does Nomad determine, and memory as well, hopefully, right? Available CPU and memory. Let's see if we can environment expecting. Yeah, I might find. I'm not sure I'm going to find this right away. I may have to get back on this, but definitely resource utilization is an important thing. And I do believe that the Nomad jobs that start. I believe that Nomad itself determines from each client, how many CPUs are available. Okay. I'll just have to double check on that and find out exactly how that's done.
Thanks, Roger. So next question, someone's asking, is Nomad a replacement for Kubernetes?
Sorry, let me just, is Nomad what?
A replacement for Kubernetes.
Oh, yes, it absolutely can be. It is competitive with Kubernetes. Kubernetes also schedules applications. Now, Kubernetes is primarily limited to Docker containers. Not to say it can't be used. I think Tectonic is a version, or CoreOS, which was acquired, I think, by Red Hat, did some stuff or had some stuff where they could run Rocket containers. But most workloads in Kubernetes do have to be Docker, and it can be convenient with Nomad, the fact that we can run both Docker and non-Docker workloads. Another thing too is that the Nomad architecture is a lot easier. Nomad consists of a single binary. You can go here and you can download, Nomad, and that single binary, it acts as both the client and the server. So when I talk about client and server, I'm running the exact same binary. I'm just running them with a different command line option. So, unlike Kubernetes and some other things out there, they sometimes require a lot of complicated infrastructure to be deployed before you can even get started, right? You need all kinds of different things to manage, variety of things. Like my experience in the past is that you might need anywhere from 8 to 10 or even up to 20 different VMs just for the infrastructure, the runtime infrastructure of these different kinds of things, whether it's Kubernetes or Mesosphere, DCOS, things like that sometimes are complicated. That may not be true of DCOS. I think they have an architecture, it might be a little more, if you're talking open source, it might be a little more like Nomad. But yes, so Nomad does compete against Kubernetes. There are some cases where Nomad and Kubernetes are used together. One interesting customer, a pretty large financial services customer I'm aware of, is actually using Nomad to provision Kubernetes clusters because they wanted to have one standard for provisioning everything they do and for running jobs, both Kubernetes-based jobs and jobs outside of Kubernetes. And so it was counterintuitive when I first heard about this because I would have thought, I've done things with Terraform provisioning a Kubernetes cluster, and to me it seemed more natural to use Terraform to provision a Kubernetes cluster. But what this customer is doing is they're actually using Nomad. One of our SEs basically did some work to put that together. They're using Nomad to effectively run some jobs that provision a Kubernetes cluster, and then within Kubernetes, they use standard Kubernetes tools to provision the jobs onto the Kubernetes cluster. And then they also use Nomad for some things outside Kubernetes. Okay, next question, Amanda.
Thank you, Roger. So next question, is Console required to run Nomad? And if not, are there advantages gained with Console? Basically, we're just looking for a little more details on how Console fits in.
It's definitely not required. One of the nice things, and I forgot to mention this, and I should have, is the reason every single one of these Nomad services showed up in Console was because of something I did that was very simple. I basically have one little, generally speaking, Nomad, we have very good integration between our products. So Nomad has good integration both into Vault and into Console. And so all I had to do to register each of my services with Console was add the service stanza to each of the tasks that I specified. But that's absolutely not required. And actually what's interesting as well is Nomad can do service discovery as well. In fact, this talks about this a little bit. So this talks about how it integrates with Console and Console's useful. But you don't actually necessarily need Console for this, and you actually also don't need a Docker overlay network like what I was using. So in my case, I was using existing Docker images that came out of Docker Hub. And those Docker images were I didn't feel like rewriting the code in those Docker images and having to create new versions of them to actually do something that I could have done. So I used an overlay network and I used Console for service discovery. However, one of the things you can do that's really cool with when you do Nomad and you specify tasks is it's actually possible to do some things in the task where essentially a task, Nomad will generate certain environment variables. I'm trying to see if I can find this in here, but Nomad will generate certain environment variables. This is probably not talking about it here, but Nomad will generate certain environment variables. I think it's actually under here, interpolation. Yeah, so Nomad will generate certain environment variables for each workload. So if you're doing containers, it'll be inside the container. If you're scheduling something that's not a container, it'll end up in the file system, and there'll be a certain thing written in the file system. And so what you can do is, think about it this way. When I had service A, like the front end service talking to the catalog service, I had some URL inside that client code, the front end code, that said, hey, here's the DNS that I want to talk to. And Console, basically that had to be mapped, right? The Docker overlay network mapped that over to Console. Sorry, over to the catalog application that was listening. And one thing I should mention to make more sense of this, when you schedule these jobs with Nomad, these jobs, depending on how you do it, but these jobs, the services that I scheduled ended up listening on random ports, right? So they were listening on random ports. Now, inside the containers, they might have been listening on fixed ports, but remember, when you have containers, there's the port inside the container and the port on the host. The host level ports for these services were randomly picked and assigned by Nomad. But what you can do is, because Nomad generates these environment variables, and I can't give you the full picture of this because I didn't use it, but because Nomad generates these environment variables, if you write your code in such a way that when your code starts up, if it reads the corresponding environment variable, then it can actually bind to the correct port. So in other words, I could have totally avoided both console and I could have avoided the use of the overlay Docker network. I could have avoided that, right? I could have basically, every single service would have started up and would have said, essentially have seen, it would have read the environment variable, it would have then bound itself to the right port, and then Nomad, at runtime, these things would be able to talk to, Nomad would know where to send these things to. I just want to qualify that. Doing that might still need console. I know we can strip out the overlay network. I'm trying to think, it might still need console just to do the actual service discovery, because otherwise the two different services might not know. It depends on how you code your application, but console is not required. It's certainly not a requirement for Nomad. You can run Nomad without console.
Okay.
But it makes things easier, and certainly it makes service discovery much easier.
Yeah. Yeah, and maybe to note, all of our tools can be used independently of each other. Obviously we often will show them using them together, but they're all independent.
Right, that's a good point. And I'm showing on the screen here the different solutions we have: Vagrant, Packer, Terraform, Vault, Console, Nomad. Then there's also the enterprise versions as well, right? So, that's over on the primary website, right? We have our enterprise products, in which we also see that there's enterprise versions, commercial versions of Terraform, Vault, Nomad, and Console. But in any case, yes, and you can mix and match. If you end up needing an enterprise product, maybe you need Vault Enterprise or Terraform Enterprise for one reason, but you're willing to use Nomad open source, that's fine.
Yeah, and it really depends on each company. Our enterprise tools are designed for teams, so it's not necessarily that you're getting a better version of Nomad. It's just solving different problems that some smaller teams just don't need or have. So.
And Amanda, while we're on that topic, maybe I'll just mention that regarding Nomad specifically, most of the functionality of Nomad is actually built into the open source product. And I think, to be honest, I forget whether that includes the UI or not. It might even include the UI. But what we actually call out specifically as enterprise features are namespaces, resource quotas, something called Sentinel policies, and then something called advanced autopilot. Advanced autopilot is more of this functionality to do rolling deployments of Nomad itself and upgrades and things like that. Namespaces is kind of designed for multi-tenancy, so you can have multiple organizations or multiple teams using the same cluster, the same Nomad cluster, without interfering with each other. And resource quotas obviously let you restrict, how much memory, how much CPU across the various Nomad client nodes, particular jobs or particular namespaces can use. Sentinel policies is more about doing certain kinds of restrictions, like if you want to restrict that only the Docker driver can, if you only want Docker jobs run on your cluster and you don't want non-Docker jobs, well, you can ensure that only the Docker driver is used. Or if you want to do things like, there's some other examples as well. If you want to do something like ensure that only that Docker images all come from a particular Docker repository, or that only certain images are allowed to be run. There's a variety of different things like that you can do to restrict, basically to do some extra governance over your Nomad deployments.
Thanks for explaining that, Roger. And now we're going to get back to the Q&A. So someone's asking, can you talk about the topology of a Nomad production deployment within AWS? And do you recommend running within an auto-scaling group, number of nodes, one Nomad cluster, or one cluster per console data center? Can you kind of walk through that?
Yeah, let me see. I think one of our documents has a good thing about that, and let me just see where that is for Nomad. Let me go back to the docs, because it might be under the, notice here there's Vault integration. This might be under the internals, even under the architecture. Here we have a high-level overview. This is showing how you have clients. You generally want 3 servers or more. Nomad and Console both use something called Raft. And in fact, under the covers, they might even be using Circ. But Raft is like a consensus protocol. Every cluster, whether it's these clusters, whether both the Nomad cluster and the Console cluster, will have a leader. And in these clusters, you have to have at least, a majority of the servers have to be up and running for the cluster to keep running. So when you're running a cluster of 3 servers, you can lose one of your servers and you're still okay, but you're not allowed to lose 2, because you don't have a majority anymore. You need at least 2. If you were running a cluster of 5 servers, you would be allowed to lose 2 of them. As long as you still have 3, you'd be okay. So this is kind of showing some different things. Now, there is some support here. Console in particular has support for different kinds of federation models, but Nomad is kind of more, these can be in different data centers, different regions. So there's some advice here, there's talk here about region A and region B. So these effectively would be two different, I think, well, in the case of Nomad, I think this is all considered one cluster. No, this is two clusters, right? Because you have two regions. So these would be independent. They're not, right? These are fully independent. So within AWS, generally speaking, a Nomad cluster would all operate inside a single region. That could be spread and probably should be spread across multiple availability zones. Same thing for Console. Console, again, has some other criteria. Console has more details about certain things related to running. Console Enterprise in particular has some features related to redundancy zones. So in other words, you can do something where you run 6 console servers, but effectively you're running 2 in each of 3 availability zones. And there's only really 3. It's kind of like 3 of the servers are the primary servers, one in each, and then the other one is kind of a little bit different. It's behaving in a different.
Roger, we're going to go back to the Q&A, but since
Sure.
you this up, everyone can see this is documentation on our website, so you can absolutely go and find this on the website.
Well, by the way, one last thing I'll say is I hope that soon, I know we're working on different guides for the different products, like Terraform has specific things for AWS. So we have an enterprise architecture team that is working on different guides for the different products. And I would hope in the near future that they might have some guides, deployment guides specific to AWS and Azure and things like that. So you see Console has quite a bit of information, but nothing there specific about AWS and nothing specific about AWS for Nomad either, not yet.
We have a whole team working on that, so more of that coming soon. So next question, Roger. Someone's asking, is Console used for the DNS for the SockShop, and does it do any round robin or load balancing updated live by Nomad?
It is being used by for DNS because in particular, Console, actually what's kind of neat about Console is Console itself has a DNS interface. So Console, this is probably best seen under the introduction. Like if you look at the introduction and getting started, it talks about installing Console, running the agents, and then it talks about services and things like that. But I think in here, somewhere there's stuff about there's a DNS API, right? You see that here. So actually Console, you don't necessarily, applications can talk to Console without necessarily, and do service discovery through Console based upon, just using DNS. They don't have to, be recoded to use, even though Console does have an HTTP API that could be used by applications, the DNS thing makes it much easier, right? So as long as your applications are on servers that are configured to use Console as the DNS server, as long as you set up DNS to point to Console, then Console serves up through DNS, and that would happen. In the case of the SockShop application in particular, other than the front end, to be honest, most of those services were just, I think all the services were just running a single instance, so there was no load balancing across multiple instances. The SockShop application, ironically, is not actually set up to run multiple instances of the services. I mean, you could do it, but when I've tried that in the past, I've seen some issues with it. I don't think it's really coded for that.
Okay, and we have time for just a few more questions, Roger. So next question, someone's asking, is it possible to tell Nomad to move microservices off of a host before that host is terminated?
There is something like that. There's something called draining. I don't know where that's documented exactly, but there is something there, and those were some new features that we added at some point to be able to do some of that. Sorry, that would be under Nomad. So there is some capability of doing that, and if you look through the docs, you should be able to find that. So you absolutely can, there's a process to use to essentially move everything off of a node and then to be able to stop the node or maybe bring a new one into the cluster.
Okay. Next question. Someone's asking, do I need to log into a Nomad server to submit a job? Or is it possible to configure the Nomad CLI to speak with a remote Nomad server? If it is possible, is there a way to secure Nomad to restrict the number of people that can or cannot?
Yeah. So the Nomad, like I was using Nomad and Console, I didn't have to log in or anything because I'm using both Nomad and Console without any tokens. There is a notion, but Nomad has a system of ACLs and Console also has a system of ACLs, right? So this is probably under some of the more, like here you see ACLs under the Nomad, right? So there is a whole thing with ACLs where you then do have kind of more restrictive about what people can do. And Nomad does include both, Nomad and Console both include CLIs, right? There's a CLI, for instance, Nomad. I didn't use it or show it to you at all, but there is under the docs, there's this commands, that's the CLI commands you see. Console also has a CLI, and then both of these products have HTTP APIs, and there are also some additional libraries that wrap that HTTP API. Now, when you do enable ACLs on either Nomad or Console, of course, using the API then requires authentication, right? So if we went back to the API overview, let's say of Nomad, I'm pretty sure there's going to be something in here that ACLs, right? Several endpoints require ACL tokens to operate, assuming ACLs have been set up, right? If they've been set up, then you need to provide the right ACL tokens. So the answer to your question, I think, is
Okay, and we'll do 2 more questions. So next question, Roger, does Console inform Nomad about application fail, or does Nomad self-determine application failure?
Nomad should see it on its own. Nomad will know that they failed. In this particular case where I'm using Console, I don't know for sure whether Console tells Nomad, but regardless of whether Console is being used or not, Nomad is able to track, like we saw in the UI, right, that Nomad was tracking these jobs. So Nomad knows whether jobs are still running or not, and it certainly knows. It does know it. It must actively be checking somehow, and it's able to reschedule those jobs or those tasks to other clients.
Okay, and so last question, does Nomad have metrics in the telemetry describing why tasks can't be scheduled? So for instance, like not enough CPU in the cluster.
Yeah. I'm not 100% sure exactly what Nomad does have telemetry metrics, and so does Console. I'm not 100% sure what telemetry, but what I can do for you is try to find the actual. If we find the actual somewhere here, it's probably here. We go. Telemetry. This says what's being collected, and I think this is fully documented. So I forgot already what exactly you were asking for, but this particular link, I'll put this through the chat. I think we have chat built into this GoToMeeting, right? Am I allowed to put something in there? I don't think it's letting me. Oh, here, type. Well, here I could just put an answer in, but I don't know. Oh wait, that might just go to the one question.
You can just type answer here and then send to all, Roger, and it should show up for everyone.
Oh, I can't expand the chat. There we go. Sorry, I didn't expand it. So I'm going to just do this way, and then entire audience. Okay, so that's the URL. So you can see here whoever asked that question, if they're still on, you should be able to see the key metrics underneath by scrolling down, and then you can see the metrics that Nomad does collect. And there's something comparable for Console.
Perfect. Thank you for sharing that link, Roger. Okay, and that is going to wrap up Q&A. Thank you for powering through all those questions, Roger. I hope everyone enjoyed today's Hangout and has a better understanding of how you can run microservices with Nomad. Thanks for joining us, and a big thank you to Roger for his time today. As I mentioned at the beginning, this Hangout was recorded, and we will make the recording available on our website after processing. I will send an email out to everyone who registered with the recording link. You can also keep your eyes out on Twitter. I'll post it there usually later today. So that wraps things up for us. Thank you and have a great day. Goodbye.
Thank you very much, everybody, and Amanda.